In this example of repeated measures, we have three measurements of percentage transmittance, all made at the same wavelength, and we enter these with one row of data for each wavelength, and a separate column of data is given for each of the three ink measurements A, B and C. For the analysis, we use Analyze, General Linear Model, Repeated Measures. And the first step is to give the within subject factor a name. In this case, the subject is the wavelength, and within each subject we have the different inks. So I will use that as the factor name, inks. And within that factor we have three levels for the three inks. We click Add as a factor, and now we need to define these levels, and we do that by clicking across A, B and C, so that the three inks A, B and C correspond to the levels 1, 2 and 3. We now click Model and select Custom. The repeated measures analysis primarily aims to test for a difference between the wavelengths, i.e. between subjects. However, we already know there is a difference between the wavelengths, and what we're interested in is there a difference between the inks. So we click Inks across as a within subjects model. Continue. We now click Options, and this allows us to test for a difference between the inks. So we need to display the means for the inks and to compare these different means, and we can test for a difference, and we could choose to use either Bonferroni or Sidak, and we will choose Bonferroni. Continue and click OK. The output gives a lot of information, but we will look first at Mauchly's test of sphericity. This tests whether there is a significant difference in variances between the different inks. And as this gives a p-value of 0.571, we can assume equal variances between the inks, which in repeated measures is referred to as sphericity. We can now look at the within subjects effects test, and for the sphericity assumed condition we get a significance here written as 0.0000, actually, which says it is less than 0.0005, which is highly significant, telling us that there is a significant difference between at least two inks. It also gives us the p-values if the sphericity conditions had not been met, and these are calculated by using degrees of freedom which have been modified by multiplying by values of epsilon from the Mauchly calculation. For example, for the greenhouse geyser calculation, the degrees of freedom used are 1.709 instead of 2, which are actually equal to 2 multiplied by the epsilon value calculated here of 0.854. So we now know there is a significant difference between at least two inks, and we need to find out where this difference lies. So now we look at the pairwise comparisons between the inks, and it shows that between ink 1 and inks 2 and 3 there is a significant difference, p-values less than 0.0005. So 1 is significantly different from 2 and 3, but we also see that 2 is not significantly different from 3 because the p-value is 0.179. And this is repeated here, that 3 is not significantly different from 2, reversing the direction, but giving the same p-value, 0.179.